P is in please find this angle. So that would be right here. That'd be our angle P. And then it says PSR. PSR would be, let's change my color really quick. PSR would be this guy. So I'm looking at our lines, and I have a line here, so this must be my transversal. And we're looking at this angle and this angle. So what is angle P and angle PSR? What is that one?
180.
But what are they called?
Same side interior.
What was that?
Same side interior.
Same side interior angles. Perfect, thank you. Same side interior angles. Well, that only really leaves two possible if I just used all of them. So we did angle 5. Angle 5 was this guy. Yeah, thanks. And PSR. PSR is this guy here. So we're looking at that, and I have two lines, one here, so this must be my transversal. And angle 5 is this angle. Angle PSR is that one. So what is the correct answer for our bell work? Yeah. Corresponding angles, perfect. If you got it incorrect, oh, you know what? Someone picked D as none. I wonder if it was a mistake. I don't know. You feel weird. Okay, let's really quick, because it might help us with this homework. Let's go today's lesson and moving forward. So let's make sure we got that homework down since we had a lot of days to work on it. Who has questions from the homework? So that would be 60, 61, 62, or 63. So there were a lot of like algebra type style stuff, and there were some from the camera. So mine's going to look a little messy because I was messing with these to make them a little clearer and stuff. So it says, if parallel lines are cut by a transversal, then alternate interior angles are congruent. Yeah.
The only question
I have. Oh, yeah, sorry.
No, you're fine, but can you switch to...
You can switch 2 and 3.
Yeah,
Yep, absolutely, absolutely. The only time you can't switch something is if the step after it is dependent on the one before it. So if I would say something like angle 1 plus angle 2 equals 180, and then my next step is their corresponding angles, you can't flip those two because you're using the one before it. But these are completely independent. We use vertical angles and corresponding angles. Can I hold it for just 1 second? I just want to see, does anyone have questions on this proof while it's up? Yeah, Cesar.
Are there different ways to do it?
Yes.
Okay.
Yep. Just make sure. The only one you can't use is alternate interior angles in here. So if you use alternate interiors, it's wrong. But there's multiple ways to get to it because we do have 4 angles and 4 angles. All you have to do is get from 1 to 8. So you can make it really complicated. You could say that these are supplementary, these are vertical, these are supplementary. You could make it really complicated, but there's tons of ways to do it. Other questions on this one? All right, Sophia, what was your... Actually, I'm going to go to Sangha because you asked one question, and then I'll go to Sangha.
Oh, me?
Yep.
The last question. 63, number 5.
63, number 5. Oh, okay, page 63. I thought you meant like number 63. I'm like, I don't think we had a... All right, let's go ahead and look at that one. So it's a good one because it showed up twice already, right? This was in your original homework the night before this. So we've seen this proof twice. So its flow is probably pretty important. So when I say prove that SA bisects BSR, so let's highlight that stuff. So SA is right here. And it's saying it bisects this angle here. All I need to do to make that true, or show it's true, is show that angle 1 is congruent to angle 2, because that is the definition of bisector, that both those angles are congruent. Do you agree with me so far?
Yes.
Yes, okay. So all we do is have to prove that angle 2 and angle 1 are congruent. Well, we are given that angle 4 and angle 5 are congruent. But angle 5 and angle 2, because they're parallel lines, are alternate interior. So 2 is the same as 5, right? And then 4 is congruent to angle 1 because they are corresponding angles. So that's why in my first step, I just said angle 5 is congruent to angle 2. So in my drawing, it would look something like this. I proved that 5 is congruent to 2, alternate interior. Then I proved that 4 is congruent to 1. So that means all 4 of those angles are congruent. By the transitive property, angle 2 and angle 1 are congruent. So by the definition of bisector, they must bisect that angle. Good? Awesome. All right, Sophia. Numero 4. Let me take a picture, and then I'll ask you for a question before I just roll through it. Like I almost steamrolled you on that first one. All right, what specific question do you have?
For step 2,
Mm-hmm.
is there a reason why you choose theorem 1 over the linear pair postulate?
Theorem 1 specifically says so if you look at the linear pair postulate versus theorem 1, theorem 1 specifically says they equal 180 degrees. That the two angles added together. So look at theorem 1 right now. It says specifically that they add to, let me read it exactly how it says it. So theorem 1 says, if two angles form a linear pair, then those angles have a sum of 180. So anytime I want to show that two angles equal 180 degrees using linear pair, the theorem 1 is the stronger of the two. Okay, because it specifically says they add to make 180. I'm showing that they add to make 180, so that is the stronger of the two in that case. Does that make more sense? Other questions? Preguntas? Más preguntas? Any more questions? Going once? Twice? All right. All right, today we're going to do a little more proof work. We're going to add kind of converses. They're called converses. So it might be a good idea to take out our pink sheet and have them open to these things. So the first converse, yeah. Hurry up, go get it. So we're talking converses. So these are good to put kind of notes by or something to say that, to talk about what we're talking about. So let's first look at the corresponding angles postulate. We already talked about that one. So corresponding angle postulate. The corresponding angle postulate says if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So note, that one starts with if they are parallel. Now the converse. The converse says if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So this is going the opposite direction. So if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. Yeah, sorry.
So, which one is this one? Is theorem 8 a converse? No, corresponding angles is a converse to theorem 8.
Not the theorem, because we're on postulates right now.
So it's a converse to the postulate?
Yeah, so we're on the postulate sheets right now.
Oh.
So we're on the corresponding angle postulate and the corresponding angle converse. So that's the CA postulate and the CA converse.
Oh.
So if we look at just the regular postulate, the CA postulate, that starts with two parallel lines, and then you can conclude that corresponding angles are congruent. In this case, we are going to start with two congruent angles, which prove it's parallel. So in this case, you're using this to prove two lines are parallel. And the one right above it, you are given parallel lines. So they go in opposite directions. So once more, the CA postulate is if they're parallel, then they're congruent. The converse is if they're congruent, then they are parallel. So once again, our converse is going to be something like this. If corresponding angles are congruent, then the lines are parallel. So why is that important? You should probably have a note on there that says this one proves two lines are parallel. So that's what it means to be a converse. Theorem 8 kind of works the same way. So let's look at our theorems. Theorem 8 says if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. So if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. So what I call this one a lot of times is our alternate interior angle converse. Once again, it proves lines are parallel. Look at Theorem 6. Theorem 6 and Theorem 8 are almost the same. They're just in opposite orders. Theorem 6 says if parallel lines cut a transversal, if lines are parallel, then alternate interior angles are congruent. That is Theorem 6. Theorem 8 says if alternate interior angles are congruent, then the lines are parallel. So when you're dealing with alternate interior angles now, you have to decide what direction you're going. Are you trying to prove that alternate interior angles are congruent and use that fact? Or are you trying to show that two lines are parallel? So if you're using the fact that you already have parallel lines, you're using Theorem 6. If you're proving lines are parallel, then you're using Theorem 8. All right, I'd have some kind of effect to that in my notes, because it'll make it a lot easier to find it. So you can kind of look at 8 and 9 as being ones where you're proving lines are parallel. That is if at the end of the day you want to prove lines are parallel. The ones before it, if you're already given parallel lines. Any questions on that? They'll be clear as we're using them. All right, so we're supposed to prove. We're supposed to prove this theorem. We're supposed to prove the theorem if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. So we cannot use this theorem. We cannot use this theorem. So what we want to show is 1 and 2 are congruent and the fact that those lines are parallel. So we are given that they are congruent. So our step 1 is they are congruent, because that is our given. Once again, our job is to show that these two angles are congruent, and we need to show that these two lines are parallel, all right, for this to work. So now let's go to our step 2. Well, we can't use Theorem 8 because that's the one they're telling us to use. So the other one we learned today is that corresponding angle converse. That's the only one we learned today. So remember, this one. So we need to create a new angle. I'm going to call it 3. So this is 100% legal to do. If you want a new angle and you're using it, you're allowed to just put a number there. It makes it a lot easier in the proof. This one says if our corresponding angles are congruent, our two lines are also parallel. So what I want to do is I want to prove that 3 and 2 are congruent, which would be corresponding angles, and then I can say that the two lines are parallel. Libby, go ahead.
I was just gonna say that 3 and 2 are corresponding.
We can't use that because we don't know they're parallel yet. We're actually trying to prove they're parallel. We're trying to prove they're parallel because I never said that these two lines are parallel. So we need to prove they're parallel, which means I need to prove 3 and 2 are congruent. Davian, or...
I mean, if you were to, oh, 1 and 3 are, if you would just put the 2 by the, I mean the 3 by where the 2 is, you can say that 2 and 3 are vertical.
You could say 2 and 3. Can we say 1 and 3 are vertical if I have it right there? Yeah, whichever direction we want to go. Your way would be fine. I'm going to go ahead and say angle 1 and angle 3 are congruent. Angle 1 is congruent to angle 3, and we said it's vertical angles.
And that proves that they're parallel?
Not yet. We'll get there. We'll get there. Now, my goal was to show that 3 and 2 are congruent. Did we pretty much do that? How do I know 3 and 2 are congruent? Songha.
Because 1 and 2 is same and 1 and 3 is same, so if you transit is
Yep, transitive property.
property and it's 2 equals angle 3,
Yep,
and it means it's parallel. Yeah.
yep. Angle 2 is congruent to angle 3, and that's our transitive property. And now I now know for certain that 3 is congruent to 2. 3 is congruent to 2. If your corresponding angles are congruent, then your lines are parallel. Did we just show our corresponding angles were congruent? Yeah, so we can jump straight to we know 2 lines are parallel. And we'll have N is parallel to P. And that is going to be our corresponding angle converse. I'll just put CA converse. Yes.
It's still a postulate.
Yes, it's still a postulate. Both your corresponding angle ones are postulates. If you get it wrong and you don't put a postulate, you don't put theorem or something like there, you'll be fine on these. All right, all I'm looking for is a corresponding angle converse. I'm looking for that converse in there though, because the converse proves that 2 lines are parallel. So once again, the steps that I did, I knew I needed to prove that N is parallel to P. And so I wanted to use the corresponding angle because I wasn't allowed to use this theorem. So I needed to show 3 and 2 were congruent, which once I did, I knew they're parallel because we had a postulate that said that. Now that we proved this theorem, now I can just look for alternate interior angles. Now, from now on, if I see alternate interior angles and I can prove that they're congruent, I can now use this theorem to say that 2 lines are parallel. All right, let's do another example. Well, we have theorem 7. Theorem 7. Theorem says if parallel lines are cut by a transversal. Ooh, I don't want parallel. Did I put theorem 7 on yours?
Yes.
I want it to be theorem 9. Change that to theorem 9.
Okay.
If 2 lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. Once again, you can shortcut this one as saying same side interior angles converse. That says converse. Let's change it to converse. Cool. Once again, pay attention to this. What this theorem is saying is if you have 2 same side angles, that are supplementary, that shows that your 2 lines are parallel. That's how you use that theorem. Once again, that is to prove 2 lines are parallel. Obviously, the very first thing we have to prove is we have to prove this is true, so we can't use it. Yeah, Libby.
Where are we solving for it? Are we solving it right now?
Yeah, we're going to do this proof. We're going to do this proof that shows it's true. So we can either use our CA converse or we can use our theorem 8. We can use either one of those in here. The only thing we can't use is this one. So we are starting with angle 1 and angle 2 are supplementary. So that's our given. So I have two goals in this one. I only can use one of those two other postulates or theorem. I can use the corresponding angle postulate, or I can use the alternate interior angle theorem. So that means I either want to show that alternate interior angles are congruent, or I want to show that two corresponding angles are congruent. That is our whole goal in this proof, which ended up, where did I end up going? Okay, it doesn't really matter. Let's just go with how we want to do it. Yeah, Labib, what do you think we should do?
Well, one and two are the same side, and that makes them congruent. So
Not congruent, it makes them supplementary.
Oh.
And we can't quite use that one yet. Who wants to give me like a next step? Davion, can you pick up your head, please? Thanks. Yeah.
You put 3 right next to the 2.
You want to put 3 by 2?
Yeah.
Sure, we can do that. We'll start with that. We'll start with that.
3 plus 2 equals 180.
3 plus 2. I want to do something first. You're 100% right. I'm going to do one step before that. Does anyone know what step I want to put before that? Sophia?
Oh, well, I just had a question.
Yeah.
Did you put angle 3 vertical, angle 2? Oh wait, no, never mind.
You could. We'll go this way and see if it works. And if it doesn't work, we'll go back. I want it one step before yours. Yeah. That works too. I'm looking for something right before it. When I write, Zizer, do you think you got it?
Angle 3 is equal to angle 1.
Not quite. Your first step should always be, if something's kind of vague, define what that means to you. Like, what does it mean that they're supplementary? Yeah. Yeah, that's always a good move. It is always a good move to, I call it unpacking the given, because there's no numbers attached to it, so I unpack it. Yeah.
Would you take that? Would you take off if we didn't put that? Substituted the numbers.
Probably not. I would have to see it.
Okay.
I think I know what you mean. Like, you just leave the definitions and you put the other definitions.
Like
Most likely, I think you're correct. I'd have to look at it.
yeah.
All right. So that is our theorem 1, right? Oh, I'm sorry. That's our definition of supplementary angles. So like I said, all I did is I unpacked the given. Now let's go down Labib's Boulevard, because he said let's go to 2 and 3. He said do measure of angle 2 plus measure of angle 3 equals 180 degrees. And that would be theorem 1. All right, the way Labib has this set up, we need to prove that angle 3 and angle 1 are congruent, because then we can use that alternate interior converse to say that those two lines are parallel. So on Labib Boulevard, we have to prove that angle 1 and angle 3 are congruent. What would my next step be trying to get that angle 1 and angle 3 are congruent? Yeah?
Substitution.
Substitution. What am I substituting?
Angle 1 for angle 2.
Angle 1 for angle 2. I don't think we can do quite that. We have to do something a little bigger. Labib?
3 for 2. Wait, no.
We can't do individual when we're using substitution. All I know is this plus this equals 180. So I know this huge thing equals 180. And I know this huge thing equals 180. Yeah? It's like that? Yeah. So do you see what? You can't substitute individual parts. The only time you can is if I say that measure of angle 1 equals something. Substitution only allows this big chunk to be replaced here. So we are now going to have, in step 4, measure of angle 2 plus measure of angle 3 equals measure of angle 1 plus measure of angle 2. But I love the substitution route we did there. Am I allowed to do this? Could I get rid of measure of angle 2 from both sides? and be left with measure of angle 3 equals measure of angle 1. What lets me do that? Well, let me see subtract. Oh, pretty much gave it away, didn't I? Yeah, Sophia. The subtraction property of equality. All right, so I went this whole route to say angle 1 equals angle 3. Yeah?
Could you do theorem 5 instead of like sub?
Yes. Yep. I use theorem 5 in mine.
5 rather.
Yep. But is this fine? Yep. All right, so we are on step 6 and we are done. We can now say that n is parallel to p. And can someone tell me how I can say that? I'm correct, but can someone tell me why I can say that? Converse. The alternate interior angles converse. Yeah, sorry. You could. Yep. The reason why I use like alternate interior angles, because when I'm on like a test sometimes, I don't want to have to, I know it exists, so I can just put alternate interior angle converse. All right, questions on any one of those steps? So now we have 3 ways to prove lines are parallel. We have corresponding angle converse, we have the alternate interior angle converse, and we also have same side supplementary converse, or same side interior angle converse. So we have 3 ways to prove lines are parallel. Yes, yeah.
So, with the alternate converse, you can say that. Oh wait, never mind.
You sure?
Yeah.
Okay. We're going to actually do, I know you're going to be sad, we're going to do one of the homework questions in class. All right? And why we're going to do that is because note that this one says, given angle 1 equals angle 4. I need to prove that angle 2 equals angle 3. Nowhere in here does it say I need to prove 2 things are parallel, but we actually do to prove this is true. So once again, we're just going to start off with angle 1 is congruent to angle 4. We should always get this point because that's just my given. And I'm going to draw that on here. So angle 1 is congruent to angle 4. What kind of angles are these? What kind of angles are these? I'm looking for same side, alternate interior, corresponding, anything of those. Our last step, so it is angle 2 is congruent to angle 3. Do you know how I know angle 2 is congruent to angle 3 using what I just said up here? Oh, okay. And we just proved they're parallel, right? Once you prove 2 lines are parallel, now I could say, well, 3 and 2 are alternate interior angles of 2 parallel lines. So we're just going to use the regular alternate interior angles theorem. Just the regular one, not the converse. So I use the converse with 1 and 4 to say they're parallel. And then I use the fact that they're parallel to say 3 and 2 are alternate interior angles. And so they are congruent. Who needs me to talk to that again? And they're just like, I don't know what just happened. Sizer.
So I'm just confused about the whole converse thing. Like,
Okay.
When do you know when to use it, when not to use it?
Well, in this homework, right, we're going to be consistently using the converses. All right. In a more realistic proof or down the road, you're just going to use that as a tool to potentially prove things. So when we get to more complex proofs later on, you're just going to ask yourself, would it help if I know those are parallel? All right, it's kind of like a tool for your toolbox. It is, now I can prove 2 lines are parallel. Is that going to help me prove something in this proof? And generally, you're going to know it because they'll be set up almost looking like it's parallel. And you're like, man, if I just prove that's parallel, alternate interior angles will get me there. All right, so in this homework, it's going to scream out, make sure you're using converses every single time, you know. But on like a test or something, just ask yourself, do parallel lines help me in this proof? And it'll probably be set up that way, kind of thing. But if not, then just disregard it for a little bit. Okay? Did that kind of answer your question?
Yeah.
All right, awesome. Other questions?